I worry though about the timing, as with always. I mean, timing is like one of the top three things in startups and technology. I think is a respectfully seems to me a lot like autonomous cars was in 2025, right? Like the Ford CEO is like, we're making an autonomous car in 2026 commercially available, stuff like that, right? That it's great. It's we need to be very careful with. I think you always have to be careful and come back to the economics. I can share again Avidbots. I'm very close to the ROI calculations and how many hours you're saving, how much the robot costs. A humanoid with the current technology we have right now, even at mass production values, like it's gonna be tough. Like you're gonna be looking at 100,000 to $200,000. So you're gonna be close to reaching like 24 hours a day of ROIs. Maybe cleaning sounds boring, or not even cleaning. Like AMRs is boring. Like sure, but it's what is hard about building a business and building a robotics company is actually not just the autonomy and the cool technologies. The other part is the operations, the manufacturing, the quality, the reliability, the service, the sales, continuous sales. I think there's a lot of. I think I worry though about humanoids and the yeah, technology is really cool. LLMs are enabling a lot of new things to be possible, but again, the hardware I worry about that. Can you make something like a humanoid bipedal with general purpose, all these things, and at the price where ROI will make a strong sense and a strong economic impetus? I can share even details in cleaning on how it's interesting how I can share a lot about the mentality of we do B2B sales, like business to business, and where people seem to start to jump and what seems to really stick. Can they get a robot to be so cheap that actually makes sense? And can it achieve all the ROI that they're after? I worry that we're a bit too early. Product of Avidbots. We are about 300-person company here in Canada. Our hyper focus is in commercial cleaning. So we make cleaning robots. Myself, I've been involved in robotics my entire career since very early in university. Have co-founded robotics teams in university, and I also worked for a few years for the Canadian Space Agency with some space robotics. And then we decided to start a robotics company, Avidbots, basically shortly after my master's. Yeah. So again, I'm also heavily involved in the community. In Canada, we have an initiative called the Canadian Robotics Council that I have been very, very involved in the industrial community side. We're basically trying to unify a single voice for robotics in Canada and try to drive adoption of robotics in our country, and hopefully get us to have like a long-term strategy. We're huge fans of the work of Denmark, China, a lot of great countries that have amazing long-term strategies. Canada certainly needs a bit of that, so we are, a volunteer organization working towards that. So,
Well, congratulations for the new release of Cash. I think very interesting. And I think we covered last time 2 years ago about the cleaning robot, but I'm curious about in the 2 years since now and what's happening now. Can you go me through what are made challenges like interesting or something with a challenge in 2 years and what's happening now and how this shaped Avidbot before going to Cans? Can you tell me how it looks like?
yeah, I mean, it's been quite a while since we released Neo. It's been 4 years. It's been a while. Certainly, of course, the pandemic happened. I think that was an interesting, very difficult time, of course, for all of us. I think it, however, did, I think, brought a bit of attention to robotics and how robotics can help in those kind of situations. We really, really liked being part of some of the. I mean, our Neo robot was cleaning in some hospitals and like the actual ward areas for COVID, where they didn't want to put humans to be cleaning; they wanted the robots to go. So it was very fulfilling to see robotics being utilized in the front lines and actually for those applications. With what we also developed also a disinfection system. As you remember, at the beginning of the pandemic, it was all about that. So we built a disinfection system. A few colleges bought them; they still use them. So they basically spray chemical to disinfect areas. So again, very happy that robotics was able to help in this big unfortunate situation. But I think that was a big thing that happened. Another thing that's happening as well, which is quite exciting in our industry, it's been a long time coming, is the kind of the new definition of safety standards. So Avidbots, we've been involved for more than 6-7 years ago with this development of the standards, but now some of them are actually published, and there's conversations about harmonizing. there is one large standard, the autonomous truck standard of ISO, that got harmonized actually, which I think is great for the industry to actually have a high levels of safety as the adopted bar in our industry for safety. So I think it's really setting the tone for the future, and that's certainly something that we have considered in the design of CAS, that basically abides by the latest safety standards. So it's good to see the industry heading in this direction, making sure the robots are good tools, right? That they're really here to help people, to work with people in unisons and with high levels of safety, so that we don't have any problems in the future. And so it's great. It's great to be big evolution, the early days of this robotic stuff. So it's great.
Awesome. What CAS mean? What stand for the name CAS? Well, like
CAS. We iterated a lot. I think I don't know if we did look at basically some origins for names. I guess so we did wanted something that was short and simple, like a simple syllable that can be easily spoken in all the languages. We sell to over 20 countries, so we didn't want something that only a certain language could speak. We wanted something a bit open-ended. I guess I'm not sure I can disclose exactly, but there is some shows that we draw inspiration from, and so there's characters that we like to steal ideas from, and so that's what it was. It's basically from science fiction work of art, and we'll leave it at that because I can't really go much deeper. But it's all from science fiction, and it's a character of a show. So that's kind of we're all engineers. We like this kind of thing. So that's where the name came from. And we changed the letters a little bit, and we like the sound of it. We did some research with some of our customers. Everybody was happy. So that's the name. I can go for a long time. It's important to give names that are androgynous to robotics. It's important to make them simple to remember and understand. And people, even with Neo, we are all humans. I mean, we like to anthropomorphize things and give them kind of a character and a thing. So the name hopefully jives well with that, so people can call it by its name and things like that.
So I would like to go for the iteration from the previous iteration and now the CAS. And you last time you told me there's more clients from DHL in airport, many clients. Can you tell me about the iteration and where the new thing is happening in CAS? Like, can you tell about the product development from your perspective as CTO? What the evolution looks like feedback, something change. If you can share more about the iteration and evolution to come to CAS here.
Absolutely. So I think the main goal is really, how do we expand our penetration in the market? Basically, there's a lot of things with CAS, and there's quite a few innovations here. I think but first and foremost, at the heart of it is really that it's designed to clean tighter spaces than Neo, essentially. So, and also with safety, though. So safety is a key part here. How do you design a robot that has got the levels of safety that you need, but is also very productive? And as you can tell, that's a bit of at odds with each other, because it has to respect the safety zones, but then it also has to be able to drive quickly, to clean the locations quickly. So the main goal here is how do we enter tighter spaces? The main thing is, as we deployed as you may know, we are deployed in Walmart Canada for lots of locations there. So about 270 robots, and so basically. As we deployed, we quickly learned that there is places that are just too tight. Neo needs 10 feet to turn around to do a U-turn. Neo needs about 5.5 feet, 6 feet to go through an aisle. And as you can imagine, in Walmart, it just gets a lot tighter. Any retail store, really, things starts getting tighter. So that's where we were trying to design that and looking at different options. And so again, with safety in mind, with high productivity in mind, we set forward to design CAS. And so that's, I think, maybe the third consideration that's also important, in addition to safety and productivity, is the cost as well. Because again, now we're looking for a smaller robot that needs to be cheaper than Neo, because Neo, if you're going to charge the same amount of money, the ROI for Neo is about 4 hours every day, 4.5, so it's 26 hours a week. The ROI for CAS is 2.5 hours, so it's almost half of the ROI of Neo. And so the cost is also almost half. Which is great. So it's also important consideration is you have to, it has to make sense from an ROI point of view. So I think it's really that combination of the safety, productivity, and target cost that has been the main focus with CAS. And I can go for a long time, and there's been a lot of work that we have done. Retail stores are very dynamic. They're very complex. There's lots of nuance there. I know, yeah, some of our competitors treat it similarly to any other locations, although they really are not. We have been for years at retail stores, really understanding all the intricacies and developing software that's specific for that. So yeah, I can go for a long time, but maybe I'll pause here if that made sense. I answer your question.
Yeah, I'm just about the safety consideration because you stressed on that part. Can you break it down a little bit about safety when you speak about in the design? It was driven one of the components safety. Can you elaborate a little more about the safety like consideration here?
Absolutely. So yeah. So again, our industry is a bit open ended right now, but again, it's slowly becoming now like unified, and there is a standard for safety, a bar. Of course, I mean, this is mobile robotics. Mobile robotics, we are not like automotive where safety is like hard requirements and you cannot even sell. So we're not like FDA, or we're not like a healthcare robot or a car where the bar is like a hard requirement. The bar is more of like a, in our industry, is a voluntary standards, but it is finally the community coming together and agreeing where this bar needs to be. So certainly in the AMRs in the warehouses, that bar is now, with the harmonization of ISO 3691-4, that's now like a very hard bar that pretty much everybody needs to follow. So to give you an idea, it's about performance level, and it's about this hazard of crushing people. So the robot needs to be very, very safe with a performance level D, or it's SIL 2 a level. I can elaborate if you like me what that means, but it's basically the robot is just, the probability of the robot colliding with a human is basically very, very low. And so that's the whole point, is robots and humans, that cannot happen because that's, a hazard, and significant hazard, and a significant impact to people. So that's not, the probability of that happening is very low. So I think slowly you're going to see all the MRs kind of getting to that level. Now the challenge, of course, I think some of the AMRs in the industry have an opportunity to solve that problem by just throwing money at it. Like they get these very expensive lidars. They're like, $4,000, $5,000 lidars, and these lidars already compute this safety, and they already give you like an output if there's a collision or not. That is difficult for companies like Avidbots that, again, are, as I just also said, the third pillar is cost. So you have to develop the safety, but not by throwing $10,000 at a bomb. That's not going to work in our industry. So this is where I think we've spent a lot of time in developing those levels, achieving that level of safety, but doing it for a lower cost. I think it was a big part of the project, and we're happy to be able to make it.
Yeah, this point's very interesting. So I'm not sure if, of course, maybe IP's related thing is here. You can't disclose everything, right? Like about the hardware and the selection, but if you kind of give high level about like how you manage to get the same reliability to know there's a distance or something, compare what we have in expensive later, like 10K. So how did they make this consideration in the hardware and you don't compromise safety?
Yeah, it's for sure. There is a lot of ways in which you can achieve basically a performance level of it. So it's called a safety critical function. So it's this chain of hardware and software that basically achieves this safety function. And then there's a probability of failure of this safety function, this chain of basically devices that work together. So there's many ways to achieve like PLD level or SIL 2. You can kind of do it, I guess maybe I can say the German way, which is the PLD is the performance level, D. I can tell you basically that means, to be very precise, means a probability of a dangerous failure per hour between 10 to the minus 7 and 10 to the minus 6. So it's a bit similar to any safety critical functions of cars, like a major failure of a major control system that will really result in that. So it's getting close to, it's not quite airplanes. Airplanes are PLE a bit higher. Spaceships are even higher, but so we're like getting closer to the cars. But anyway, so that's what PLD means. And so, okay, so to go back, I guess, to the original point is you can achieve performance level D with like the old school way, like the German way, where you duplicate things. So you put redundancy. So you put 2 lidars, you put 2 emitters, you put 2 receivers, you put 2 processing boards, and then you compute the output of the both. And then you're like, both of them are saying the same thing. So that's correct. That's one way to do it. Then there's arguably the more modern American / British way with a different safety standard at 61508, where you try and put diagnostics. So you have only one system, but then you build a lot of checks of the system, and you build a lot of basically diagnostics. So that way you can still achieve that level of safety without basically doing the redundancy way. So there's different ways, so that's kind of what we have leveraged here, and what a lot of people I know are leveraging. So yeah, I think that's again what you have to do when the cogs is really important. So
This is super interesting point. I thank you for sharing that, because we used to the redundancy in the like aircraft with sensors to, yeah, if there's one malfunction. But now you say this, I think our first time know about that. There's two way to do it. Can you tell me the motivation for that? Is it because the cost down, like hardware, you don't have to use too much hardware as a redundancy. So it's dependent here on software. You make redundancy in software, if I understood.
yeah, the software is written in a special way. Is a hardened software. The processor is also hardened, but then we have a lot of diagnostics. So we're checking all of the stages of the safety chain, and if anything goes wrong, then we pull the system, and the robot will stop. Right, essentially. So yeah, that's the difference, and then you just look at it more carefully about the different stages and all the failure modes, and then you make your safety case, and you achieve it in that fashion. It is different. Yeah, a lot of other people. Go ahead. I don't know. I guess the other way is just you can use basically a component that you don't understand too much and you don't have any diagnostics, but if you kind of double it up, you can prove. It's all about basically proving a probability of failure at the end of the day. So if you have two systems with a certain failure, but then you are checking the output of both, then you can argue higher levels of safety. So you don't need to put as many diagnostics or as much intelligence in the system, because you just are doubling it up. So if two of them are computing the same thing, then it must be correct. So it's all about really detecting the failure and failing in a safe way. That's ultimately the goal here. Yeah.
Interesting, super interesting. Maybe I'm curious about your perspective of the CTO here when you design the thing, like extreme use cases, extreme cases of failure. Like you try to make this safe as much as possibly can. Retail people work with that. Non-lay people don't understand. So how you consider the like extreme case that could happen as a failure? Like, can you tell me how you imagine situation you look for, like incident in workplaces or like retail, to design to make this decision how the system looks like to be redundant and safe?
Yeah, absolutely. So we do what's called a hazard assessment. So and this is the whole idea of a safety standard, right? Because different OEMs are going to assess the dangers differently. That's why it's important that we come together as an industry and we're like, okay, this is the bar. We kind of need to be above that bar. And that's the whole point of safety standards. So I would say the key difference between an AMR that operates in a warehouse, the standard I mentioned, ISO 3691-4, versus the standard that I was very involved developing, that we've been doing for about 6 years, the IC 63327. Actually, to my knowledge, that would be the very first standard that covers a robot like CAS or Neo in like a mall or a grocery store or anything like that, right? So it's an open-ended environment. Both the standards are calling for the main safety critical functions that we deal with. One of them is the crushing that I described. So if there's a person and the robot, we don't want the robot to crush the person to a hard wall, because that would be a very big impact. That's already handled in 3691-4. That's also in our standard. However, the extra thing we have in our standard is also surface elevation change. So if you have a cliff, that could be very harmful, right? If the robot falls off a cliff, it's a very heavy machine. It can topple over. It can crush somebody. That would be really bad. A lot of energy, right? Like energy when you have even 1 meter is like tremendous amounts of energy that you're accumulating. So it's not good. So that's the whole point. Is this standard also? We also have then sensors in our robots that are particularly designed for cliff detection, and is actually verifying that there's no way that it can happen. So that's I think the difference. And yeah, I think there is already a Japanese standard that's really old, is over 10 years old, that was doing the same thing as we are in our standards. So I think we're in the right track. I think this standard is going to take a few years to get harmonized, though. Harmonization, it's a long process, and it is in Europe, by the way. In North America, the standard is already present, it's already a thing. But there's differences between North America and Europe, how they handle the standards. But yeah, in Europe, it's going to be a few more years, but it's coming. It's like 2-3 years, and I think once that it settles, then that's probably it. I mean, it's going to remain as the de facto way to do it. So
Just out of curiosity, when you have the client like people outside of North America, I'm assuming there's different consideration like the privacy. I'm not sure the data, how the hardware consideration. Do you have like a challenging with this, like which region you have to like work with client and you have to adapt your the hardware or software? Is there something also you do that or like adaptation to the hardware?
yeah, privacy is really important. Yeah, absolutely. I mean, privacy and there's different jurisdictions with different laws on privacy and what you can do, cannot do. I think that's a big differentiator. Also with Avidbots, we have a ISO 27001 certification. We're very careful with how we manage data. We are GDPR compliant as well, GDPR compliant. Yeah, we have all these controls in place inside of our company. So yeah, I agree with you. I think it's very, very important. It's not something that every OEM will do. Some OEMs have like no rules about it, which is tricky. But yeah, always the data is owned by the customer. We are always here we only use it for, monitoring controls. We don't, sell it or anything else like that. It's all in our agreements. It's all clearly documented. Yeah, I agree. I think it's very important. And I do like how the governments are taking a more active stance on that. I think is important. Sometimes they go a little far. There's some rules, there's some conversations happening where it's going to get really, really complex. But I do think something like GDPR, well, maybe a little tough, is certainly in the right direction and certainly a good way to do it. So I hope more jurisdictions adhere more to that kind of standard. Yeah, I am happy to see how it's evolving. And yeah, it's going to be key for robotics. I think robotics will continue to be like this for a long time. And yeah, I think as long as OEMs respect the data and respect it is really customers' data and handle it properly, I think, yeah, I would think that problems happen when that's not the case, right? Where you have this very, very bad user agreements and the users never read it, and then they don't, yeah, OEMs are not responsible. I think that's where things go south, and I think it needs to be respected. So it can be done properly, I would say, I think.
So since to go to the end of your question, maybe I won't ask about the challenges so far, maybe where you came to cast like, and do you have like any moments with you with the team, like it was quite challenging or hard to achieve?
I think it's always tricky to, yeah, like to decide really like direction of the product design. I think there's a lot of ways to, I mean, maybe making an analogy to cars. I think if you want to make a sports sedan, there's like 5 different things you can do, right? You can make a BMW M3, you can make an Audi S4, you can make a, and it's not wrong, right? Like the decisions to make a rear wheel drive, 400 horsepower car, I mean, versus the Audi, like all wheel drive, like you see, there's so many ways you can do it, right? There's so many different angles you can take and innovations you can take and positioning victories you can take. And so I think there's, it's just hard. It's hard to nail that and agree. And it's hard to also agree internally because everybody in the company has views as well. So I think that's been a bit of a challenge for us to decide and move forward. And yeah, certainly is also a challenging project because we are introducing, again, safety and productivity. There's a lot of complexity in the robotics control software. We're still definitely improving that. So I think it's been quite a while, but we're very happy. We're happy to finally be here. I guess another thing too is definition of a bit or design language as well. That's the other thing that we are happy with CAS. We are making an interesting stance in the cleaning industry. Like CAS doesn't have any visible hoses. It looks, it has a injection molded panels, and so it looks like a robot. And let's see, I think so far it's paying off. Customers are really happy with that. They're running it in the morning, a bit like a marketing play, and they're very proud of the way it looks and happy that it shows their innovation. So those are interesting gambles we have taken. That we'll see how it pans out. But I think all of the decisions is taking a while, but we're happy again to be here and to basically have a very good product. We're really proud of. So we took our time, but it was a good thing. We're very happy.
Yeah, definitely. I was curious about this part because, the first iteration, of course, I think there's this significant shift in the appearance. It looks like a robot, and it's really interesting. I was curious about, besides the functionality, which is important, the the connection. Like when you see the robot is attractive. Like, can you tell me about this design consideration? Because I think I assume it's not easy, but of course you have the experience and the consideration to have this attraction as well. It's not like something rigid, something.
Yeah, no, I think if anything, we have some research projects that, again, we haven't had a chance to release completely, but I do agree. I think is a huge untapped power that we have as roboticists to connect more with the user. Whether we like it or not, it's just human nature to want to anthropomorphize like a machine and start to think of it as an entity. Perhaps even more in Asian countries where they, the word robot means like, I guess, mechanical human. And you probably know this better than me. You've probably done some research on that too. But it's mechanical human. That's the meaning of the word. The word they use in Japanese for defining a robot. So they even in their language they're thinking of it as a human, which is awesome. But that I don't think all countries are that forward thinking when it comes to that. But it's just the reality. So we have tried to anthropomorphize it. We are planning basically a family of robots with different characters. The Kaz, we maybe didn't come out too well, but we thought of it as a hermit crab, so a little brush thing at the front and a bit tall at the back, so it's doing sting and cleaning, and so there's a bit of a character that we've tried to put into the design. Also, as I mentioned, we have now design language things about Avidbots, the side lights, the curves, the center, black center is also hopefully something we're going to carry across the fleet in the future. And so, but overall, I think we couldn't do it. Just to give an idea, we wanted to have a screen as opposed to the two eyes. Right now, it's just static, but that is something that we're looking into, and not just us. I think it's already in the industry as well, because it's important to communicate more. I think that's one thing that is untapped right now. How can you tell the human in the facility where you're going, what you're intending to do, and any kind of sound as well, feedback maybe. So there's a lot of ways to really increase that communication, both from the robot to the human, and then it's hard for the robot to communicate much with for the gesture of a human to be interpreted by a robot. That'll be quite complex, but there is some work. I mean, you can do dynamic obstacle avoidance, you can predict their motion and kind of avoid it, but that is certainly something that we're looking into, and it'll be I think it's an untapped power that we have in the industry. I think even the fact that people, again, when we designed Kaz, we designed it, we knew it mattered a little bit, but the looks and the eyes matter so much more than we thought ever mattered. The more feedback we get, the more positive that is from people. So I think it just validates it that it's now part of the environment. It's an entity, and there's all this research about trust. So I think it's important that roboticists remember that we have this power that we're not tapping too much to build a deeper connection and to communicate better with the user, for sure.
Absolutely, it's a really important point. Maybe two questions. The first one about when you see what happening in robotics now. You mentioned about the design of CAS. I think you didn't go for something crazy, but I think I can see it's positive when you say the feedback, and I can imagine that. But when you see the embodiment intelligent robotic now and using the large language model and he's saying, so do you see that something you can do, or you still have the limitation how CAS is perceived? It's not like, you know what I mean? It's just like spectrum where it looks like compared what we see in humanoid robotic, for example. So
well, I think cleaning is gonna be our focus. We have so much more to do in cleaning. We like to have a fleet of different robots. I think there's quite a few years for us to really own that market. Humanoids is interesting. I think, happy for them to have the attention that they're getting. And yes, I agree with you. I think the fact that they are humanoid maybe touches deeper to the humans and makes us a bit more attracted to that idea. I think again, I kudos to them. I'm happy that they're raising so much money and being able to make the impact that they're making. I again, I wouldn't pretend that I'm an expert at LLMs or humanoids. I follow the space in the periphery. I think I high level understand. I worry that I think they're onto something, no doubt. Like I mean, the fundamentals of the potential that this technology can have in the whole industry and humanity overall is amazing. I worry though about the timing. As with always, I mean, timing is like one of the top three things in startups and technology. I think is a respectfully seems to me a lot like autonomous cars was in 2025, right? Like the Ford CEO is like, we're making an autonomous car in 2026 commercially available, stuff like that, right? That it's great. It's we need to be very careful with. I think you always have to be careful and come back to the economics. I can share again Avidbots. I'm very close to the ROI calculations and how many hours you're saving, how much the robot costs. A humanoid with the current technology we have right now, even at mass production values, like it's gonna be tough. Like you're gonna be looking at $100,000-$200,000, so you're gonna be close to reaching like 24 hours a day of ROI. So you're gonna need to. There's some complexity there that I think I worry whether or not is the right time. I worry that it's again with a much cheaper solutions and more narrow focus solutions, you can achieve similar ROIs, if not better, for a much lower cost. I think that's the thing that we need to keep in mind and be aware of. And that robotics is hard. I mean, even again, having done cleaning, I can show you so many examples of so many of my peers that are doing something with a very clear ROI, like bang on, like even just developing the tech, getting it to be reliable, getting it to work all the time. Maybe cleaning sounds boring, or not even cleaning, like AMR is just boring, like sure. But it's what is hard about building a business and building a robotics company is actually not just the autonomy and the cool technologies. The other part is the operations, the manufacturing, the quality, the reliability, the service, the sales, continuous sales. I think there's a lot of. I worry though about humanoids and the technology is really cool. LLMs are enabling a lot of new things to be possible, but again, the hardware I worry about that. Can you make something like a humanoid bipedal with general purpose, all these things, and at the price where ROI will make a strong sense and a strong economic impetus? I can share even details in cleaning on how it's interesting how I can share a lot about the mentality of we do B2B sales, like business to business, and where people seem to start to jump and what seems to really stick. I can go, let me know if you'd like me to open that big topic, but it's stuff is low. So I will be surprised. I worry that can they get a robot to be so cheap that actually makes sense, and can it achieve all the ROI that they're after? I worry that we're a bit too early. It's just like autonomous cars. Like we are seeing some nice early results, but then from there to it be a technology that's going to stick around and make sense and all that, there's a gap there that I don't know if they're able to assess or understand at this point.
Do you do a subscription model? Like if you have the hardware, you have a subscription for the client, or how it looks like? You sell the hardware and that's it.
No, absolutely. We have a rental plan where you can rent from us. We also, the one that is becoming very, very, I guess, utilized right now at Avidbots is this leasing model that's working out really well right now. And then there's, of course, the main CapEx. Rental certainly has been a little tough for us because we have to put all the upfront costs, and then it makes sense for us in 2-3 years down the line. So it's been a little tough on our books, and we have tried to avoid it. But the leasing is going very, very well right now. So to give you a rough idea, like leasing for CAS would be about $2,000 a month. So it's really, really good. So yeah, and if you do a 5-year lease, it's like 1,500. So it becomes quite good, and I think that's something people are really adopting right now, and it makes a lot of sense for them. So I think that's something all the robotics companies should look into for sure.
Okay, awesome. So the next thing, I'm not sure if you can share much, but of course, like in generic way, like in cleaning robotics, what is the next thing or the next iteration? Of course, I believe that's something related to change the product market fit, how the customers have the feedback, and it's really positive so far. But how you like think about the next iteration of the Avidbot robots here?
Yeah, as I was saying earlier, we want to have a fleet. I think we have a lot to grow in terms of like bigger robots, but also smaller robots. I am personally pretty excited about the smaller robots. There's a market that's growing really, really fast. Um, yeah, again, to as I was saying, like there is one of our competitors that's selling a smaller vacuum. It's a basically a 20-inch vacuum, so it's not as small as a Roomba, but not as big as a CAS. So somewhere in between CAS and a Roomba, and it's a really exciting market. They're able to rent the robot, lease the robot for about like $600. So that's where, and that's, by the way, just to give you an idea, again, our goal as an industry should be to be in the millions of units, right? That's where I think we're going to see the explosion that we all want to see. Uh, right now, I would say like CAS or units like Neo and CAS are in the many thousands, maybe less than 10,000, basically industry wide. But the smaller one, it's like in the tens of thousands, in the highs, many thousands per year. So that's where I think and it's interesting, this economic impetus conversation, right? $1,500 for CAS is maybe too much, but when it start touching the 500 line, there seems to be some more openness to do it, and so I find that a very interesting number. I think we all need to be paying attention. I think there's also that discussion about a general purpose robot of a building. What does it do? What is it that it does? What it doesn't do? Again, how can we make millions of this thing? And I'm curious if that $500 line is kind of the line that we need to go below to really start seeing an explosion. And if we can do cleaning and it can do other things, then that's where it could get interesting. So yeah, that's in a nutshell. I think, yeah, we need to grow. And then, of course, cleaning is our 101 priority. But after we have a very good penetration with cleaning, we're quite excited because there's quite a few things. We already experimented with disinfection add-on. We learned a lot. I think there's other add-ons that people have been requesting. We've been thinking about it. So there's some of our competitors do shelf scanning in retail as well. So they have a cleaning and then also shelf scans and gives you planometry and all those kind of things for retailers. So yeah, I think that's probably where a lot of these things are going, where hopefully, yeah, let's see that one day where there is a general purpose robot that is able to do those things and able to serve people and be in a building and become more everyday life. That's everybody's goal, I think. So it's there's some interesting early signals of where pricing needs to be and functionality needs to be and value. So I think it's let's see how it goes, but it's exciting to be part of it for sure.
Maybe if you have final words like to say with listening.
No, I guess just very excited to be releasing CAS, to be basically opening up the market and being able to serve a lot more people. We've spent a lot of energy on CAS and making it very, very easy to use and a seamless experience. So I think that's certainly something we are putting a lot of emphasis on and resonates a lot with customers. That would be my recommendation for other people to really focus on providing a really good experience to the customers and seamless. I think that really resonates and helps build a brand. And yeah, we just gotta enter the market now and make it happen. And so yeah, looking forward to putting a lot of CASes out there and delighting customers and saving them money.